All right. Well, good afternoon, everyone. Welcome back to the class. Today we have a special guest. We're interviewing Chris Butler from our own ITS here at RIT. Welcome, Chris. Thank you very much for joining us.
Nice to be here. How are you?
Very good, very good. And welcome to my dining room. Before we get started, I'm supposed to give a shout out to my nephew, Brandon Bear, who apparently watches these even though he's not a techie. All right. Chris, can you tell us a little bit about what you do at RIT?
Sure. So I've been here 18 years. I've done various support roles in the library and now in central ITS. Today I work in the RIT data centers, and I support central storage, central compute, basically kind of cloud infrastructure.
Very good. Now, we have been talking about enterprise computing and all of the aspects of enterprise computing. So we've been covering the network and virtualization and cloud and eventually data centers and SDN and DevOps and all those kinds of things. When I say enterprise computing, what does that mean to somebody like you?
When I hear enterprise computing, I think traditional corporate data center. Today, all the buzzwords seem to be pushing for like software-defined data centers, software-defined networking, cloud computing. So I think the terms are being replaced, but essentially it's the same thing. It's typically compute assets in a company and typically in their own data centers.
All right. Great. So RIT is a fairly large organization in terms of number of students, number of faculty, and so you deal with a lot of systems. Can you tell us a little bit about the scale and maybe cost that some of these things that you're getting into?
8 years ago, I started in the data center and came over here. They had 2 VMware hosts and a few dozen virtual machines, and not a lot of budget, and I don't know, not a lot of interest in using it either. It took a few years, and we had to tackle storage services and backup services, network services. How do we scale? How do we do it quickly? Kind of meet demand. So within a couple of years, we found a storage solution that would scale pretty much infinitely. Backup solutions that work pretty well in hundreds of terabyte backups a night. And then we started offering kind of hosting services where the 20-plus IT groups across campus, they have their own budgets, their own hardware, their own potentially facilities. They started looking at us, and when our prices got to an attractive point, they started using some of our services. So very quickly, we went from a couple hosts to a couple dozen hosts, and basically in 5 years, we scaled memory, CPU, disk, 10,000%.
10,000%.
Yeah.
Wow. Wow.
Yeah.
So what are some of the most significant issues that you have to deal with in an organization of this size? What are some of your day-to-day concerns?
The traditional stuff, high availability, security. The main thing is scalability. So as we grow, we basically double every year. And the number of services running in our shared environment doubles every year almost. So with that, we always have to worry about constraint, bottlenecks, either not allocating enough hardware and time and running into performance issues, or basically having bottlenecks and having service degradation. So scalability and making sure that we have the proper hardware life cycle to deal with it, that's our main concern for me.
So just for fun, let's try to put some numbers on some things here. So when you look at virtualization footprints, so virtualization or VMs to the physical machines, what kind of ratios are you looking at? And maybe how much storage are we talking about? I mean, what kinds of machines, what kind of physical infrastructure is used to support this stuff?
So like I said, 8 years ago we had 2 hosts and a few dozen VMs, so maybe 5, 8 VMs per host. Today we average probably about 45 to 50 virtual machines per host. And that's in the production environment where things like Exchange, those virtual machines have 64 gigs of RAM each, 12 plus CPU cores. So there's some very big beefy VMs in there. If we had a smaller sampling of VMs, we may be hitting 100 VMs per host. But based on our ratios, about 50 VMs per host. We have 6 to 8 terabytes of RAM in production. We just added some more hosts. We probably have about 1.5 terahertz of processing power, maybe approaching 2 terahertz, and about 1.4 petabytes of storage.
So you're talking about a fairly large set of hardware to support all of this stuff together. What's your favorite vendor at this point?
So our favorite vendor used to be HP because the blades, we're buying blade systems from them mainly because they're dense, easy to put new hardware in, and they have shared network uplinks. Back 6-7 years ago, one of the top constraints time-wise to get new hardware into production was getting network ports, getting fiber run, getting complex VLAN tags configured on all those ports. So we bought blade systems to basically kind of make it plug and play. Here's another host, give me an hour, it's up in production, and no request to the network team. Today, we've switched to top-of-rack 10 gig switches, Nexus 9000 series. So very dense 10 gig ports. They actually have 8 40 gig port uplinks that you can use. Because those are easier to configure and easy just to take copper cables and plug in, we're switching back to standalone. And actually right now we're buying from Dell. So Dell is now our preferred vendor.
All right, very good. So you mentioned some of the, oh, we got a little choppy there. You mentioned some of the, maybe the processing power and some of the RAM that you have available, but you've also said that you're part of the storage arm of RIT. How much data are we talking about here that needs to be stored long term?
It seems like it grows indefinitely, and purging data just never seems to happen. We have a data retention policy, and people are supposed to delete certain types of data after 12 months, or after 6 years, or maybe after 12 years, depending on the data type. Mm-hmm. But no one really does that, probably because we don't have the tools to tag ownership of the data properly, classify the data, and apply those retention policies. So it grows indefinitely, and what needs to be stored, don't know. We don't really see what is stored in our environment. We just see it grows every year. So let's see. In March of 2013, we had a power renovation, and we had to move our storage to new racks. So we had to move about 115 terabytes of service within 2 weeks, basically 30 feet. So we worked around the clock, got that data moved about 5 minutes before the power outage. And so that was, what, 18 months ago. Today we have 350 terabytes of virtual machines, and we are bringing in tens of terabytes, if not potentially hundreds of terabytes of data, file services data, outside of VMware, but within our same shared storage environment. So, we'll probably by end of this year have 0.5 petabyte of data to somehow protect.
And do you have concerns for moving any of that data off-site?
Today we have 2 data centers on site. They're about 400 meters apart, and we have about the equal capacity on either site. So our intention is for these large data sets, like hundreds of terabytes of file services, to replicate and store many recovery points in each site. So if a site goes down, we fail over to the other site. If data gets corrupted, we can roll back from either site. But there's still a concern that the proximity of those 2 data centers puts risks of that data. So we just moved over $250,000 of storage hardware to Syracuse. We have a 10 gig Lambda that goes out there to extend our network from campus. And we'll start probably with about 30, 40 terabytes of data replicating. Basically three ways: synchronously on site, async to Syracuse. And so even if the campus goes down, we can recover critical services there.
So you said something interesting earlier about contacting the networking team when some of this stuff has to happen. So when we're talking about data, we're not just talking about something that lives in isolation, are we? You mentioned VLANs, top-of-rack switches. So if you could just speak to, one, what do you consider a top-of-rack switch, and two, maybe how important it is to interface with the networking guys?
So traditionally in ITS, there's been silos of roles and responsibilities. So you've had the storage team, the Unix team, the Windows team, the backup team, the network team. The roles are starting to blur, and they have to, as all of our technology is interfacing with everyone else's technology. So VMware isn't just about servers, it's about storage, it's about networking. The network team needs to know what's going on in our environment, we need to know what's going on in their environment. The roles need to break down, we need to work together. So when it comes to networking in particular, that's what fits it all together. We've got our storage, which is IP traffic, iSCSI. We have back-end networks for our clustering. We've got front-end networks for our services, virtual machines. But it all shares the same cables, the same fiber connections. And as a network team, it's very critical to make sure that we don't saturate connections so that we have proper monitoring in place, and that we can scale.
Well, that sounds like a really enlightened sort of view compared to some of the very traditionalists that we have out there. Networking lives here and storage lives there. It seems like enterprise computing covers a lot of ground. What are some of the interesting projects that you have worked on or might be working on that might fall into this sort of area? You mentioned the data center move. Anything else going on?
So with the new facility in Syracuse, we're trying to spin up kind of a disaster recovery as a service, allow our application owners to be able to monitor the data that gets replicated there, but also on their schedule, push button recover apps or test the recovery of their services without calling us, without engaging us. That's one of the most recent ones.
So is that over and above what you might do to restore a VM then?
Yeah, so we have backups for file deletion or corruption. We have the ability to recover whole virtual machines. But to recover whole services if the campus goes down, this new facility in Syracuse allows us to, at least for critical services, bring them up within 20, 30 minutes, regardless of their size. My courses is about 14 terabytes, and we could probably recover that in about 10 to 20 minutes, basically from SAN snapshot, and we would probably lose about 15 minutes of potential data. Between data centers, we can synchronously replicate, no data loss, probably 15-minute replication cycle for offsite. So that's one kind of self-service feature we're trying to bake into our environment. We also have to look at like desktop support, virtual desktops, application streaming. There's dozens of stuff that we can roll out from a service perspective. Staffing is our limitation.
All right, very good. So we've talked about some of the things that you do, and you mentioned that one of your biggest issues is scaling. Is there anything that you would consider critical for students in an enterprise computing class to know about?
If they're going into a data center role, or they're going into cloud computing, if they're looking at working for Google, Amazon, these large companies, Silicon Valley, I think diversifying the skill set, don't focus on one thing. It is great to be a specialist. I think everyone should specialize in something. but you also have to be a generalist. You have to know how everything fits together. I think those large companies today, they're looking for a diverse skill set, and they're looking for adaptability. How do I all of a sudden take a new piece of information or technology? How do I integrate that into what's already there? So can't get stuck into a certain technology. It's changing too fast, and you really have to get a feel for everything that is out there, so at least you know how they fit together.
All right. Two more quick questions for you. Is there something that you would consider to be a really hot topic as far as something that's emerging that might be of interest to take a look at?
I don't know. SDN. So in our environment, I was saying networking is very critical to how everything fits together, storage, servers. If you look at traditional networking, you typically have maybe an active path to this router and a passive link to another router, or you have certain switch stacks. But when the traffic is just all flowing in one direction, it's easy to hit a bottleneck. And it's not something you can just throw 100 gigabit at. It may be too costly to do something like that. I love the idea of SDN, software-defined networking, and that you can start putting intelligence into the network that adapts to changing loads, adapts to location of where the services and data are, and starts to change the flows of the traffic. So starts generating policies based on priority of the data, locality of the security hardware, locality of the storage, and intelligently routes the traffic, hopefully in the most efficient way, but also in the most distributed, load balanced way. Today we do everything kind of static, including our storage. We statically assign paths, we statically assign policies there. But as this stuff grows and scales, it has to be dynamic, and it has to be orchestrated, at a large scale, not individual components.
Well, I think you just caught the heart and soul of SDN right there. All right, the last question I have for you is there anything that you would like to impart to the students, any pearls of wisdom or anything that you would like to make sure that they look at as we sort of exit this really large and complex topic that is enterprise computing?
Find something you're passionate about. I've been in this role for 18 years. I've got another 25 to go, and the technology is going to be so different in that period of time. Find something you're passionate about and enjoy it. Make sure it's not feeling like a drudgery. You gotta go to work with a smile and a bit of curiosity so that you can keep on moving with this technology evolution.
That's a good piece of advice right there. Chris, thanks very much for your time. We really appreciate you sharing your wisdom and your thoughts on enterprise computing for us. Thank you very much.
My pleasure. Have a good day.
All right, you too.
Thanks.
All right.